Hello friends, now today we will study one of the problem from assignment model category. This problem comes under the assignment model, which is a part of operation research. This is one of the operation research model. Now the problem is given like this: solve the following assignment problem. So it is clearly mentioned for minimizing total time required to complete 5 tasks. Okay, so there are 5 tasks as given. Matrix given below shows the time required for each worker to complete a task. Okay, so problem is like this: task, or here we can call it as a job. Okay, task or job. Okay, so there are 5 operator, or this can be considered as worker or the operator. Now these 5 operator are able to do these 5 jobs. Okay, so but there are some restrictions. Okay, here you can observe the restrictions as given. That means this first worker cannot do this a job. Okay, so here is the restriction given, this infinity, or sometimes here it is simply dash is provided. Okay, so that means this first worker cannot do a job, this second worker cannot do this b job. Okay, it means that these are going to be the restrictions in this particular problem. Okay, so it is not required to that this particular restriction should be this diagonally. Okay, it can be anywhere, or it is not required to that every particular job should have the restriction. Okay, it can be only one restriction, or it can be restriction at each worker, or at each row. Okay, so it depends upon the type of the problem. Okay, so here each worker is having one restriction, right? So first worker cannot do a job, second worker cannot do b job, third worker cannot do c job, fourth worker cannot do d job, and fifth worker cannot do e job. Okay, so these are the restrictions for the particular worker or the operator to perform the task or job. Okay, so this is the one of the category of assignment model problem. Okay, so generally it is called as problems with problems with restrictions. Okay, so these restrictions are some limitations. Maybe the a first worker will not have the skill to perform the a job, second worker will not have skill to perform the b type job. Okay, b means in the sense it may be any type of job. Third worker cannot have, or is not having, a c type skill, okay, to perform the c type of job. Okay, so it means that it is some type of limitation whereby that particular task cannot be done by that particular worker or operator. Okay, so we cannot make assignment here. Its simply meaning is that one a job cannot be assigned to one, b cannot be for two, and c can be for c can be for third worker. Likewise it is given. Okay, so let's see how to solve this particular problem. Obviously we are going to solve this particular problem by using one of the, or this is the only method in the assignment model, that is Hungarian method. Okay, so by using this method we are going to solve this particular problem. So here now it is given. Okay, so these are the 5 jobs: a, b, c, d, e, and these are the 5 tasks that has given. Okay, so now let's see how to solve this. Just there is only one difference between normal problem and the problem with the restriction, is that we are not going to make any change here. Okay, so whatever is given here, we are not going to make any change at these places. These are going to be as it is. Okay, and whatever the common operations are there, we will follow as it is, as like a common problem. Okay, so the first step to solve the problem is to check it whether it is a maximization or minimization. So okay, so it is directly given in the problem, it is a minimization problem. Second thing, there are 5 jobs and there are 5 operator. It means 5 rows and 5 columns, so it is balanced. So directly we can move to the row minimization method. Okay, so the first step is row minimization. First step is row minimization. Now in this we are selecting smallest value from the row and we are subtracting from entire row. Okay, so now while selecting, neither we are going for this place where restriction is there, nor we are adding or subtracting, nothing. Okay, so we are not going to do any operation at this place wherever restrictions has been given. Okay, so let's see. In the first row, smallest element is 4, smallest element is 4, so we'll subtract it. First of all, we write down here infinity as it is. It can be infinity or dash. 7 minus 4 will be 3, 6 minus 4 will be 2, 8 minus 4 is going to be 4, and 4 minus 4 is going to be 0. Okay, in the second row, first of all, we'll write this infinity or dash part as it is. In the second row, smallest element is 5. Okay, so we'll subtract it. 7 minus 5 will be 2, this restriction as it is. 8 minus 5 will be 3, 5 minus 5 0, 6 minus 5 will be 1. In the third row, smallest element is 6. Okay, it is a 6. Okay, this infinity will be as it is. Smallest element is 6, 6 minus 6 is 0, 8 minus 6 is 2, 9 minus 6 is 3, and 7 minus 6 is 1. Okay, in the fourth row, infinity first of all will keep as it is. In the fourth row, smallest element is 5. Okay, so we'll subtract it. 8 minus 5 is 3, 5 minus 5 is 0, 9 minus 5 is 4, and 8 minus 5 is 3. Okay, so in last row, smallest element is 4. We'll keep sub infinity as it is first of all, and then we'll move for the next process. 4 minus 4 is 0, 6 minus 4 is 2, 7 minus 4 is 3, and 8 minus 4 is 4. Okay, so we have done with the row minimization operation. In the second step, operation will be column minimization. Okay, operation will be column minimization. Okay, now in second step of this column minimization, second step is column minimization. That means selecting a minimum element or the least element from the column and subtracting it from that entire column. Okay, so while solving here also, we will not do anything or any operation at the cell where restrictions has given. Okay, so the first column infinity will be as it is, this restriction will be as it is. In the first column, smallest element is, or smallest value is 0. When we subtract it from entire column, it is going to be as it is, the numbers are going to be as it is. So 2 minus 0 is 2. Okay, 0 minus 0 is 0, then 3 minus 0 is 0, sorry 3, and 0 minus 0 is 0. Okay, in the second column, first we'll update the restriction, and then we'll start with the operation. Smallest value is 0. Okay, so we'll write as it is. 3 minus 0 0, 2 minus 0 0, 0 minus 0 will be 0, 2 minus 0 will be 2. Okay, in the third column, smallest value is 2, okay, so while doing this, 2 minus 2 is 0, 3 minus 2 is 1, here infinity as it is, 4 minus 2 is 2, and 3 minus 2 is 1. In the fourth column, smallest value is 0. Okay, so this column will remain as it is. 4 minus 0 4, 0 minus 0 0, 3 minus 0 3, infinity minus 0 will be infinity, or we are not making any changes there, and 4 minus 0 is 4. Column E, smallest value or the smallest cell is 0. Okay, again it is remains same, 0 as it is, 1 minus 0, 1 minus 0 1, 3 minus 0 3, and infinity as it is. Okay, so this is how it is going to be there, that all these values are going to be like this after column minimization. So now once we will get this, or once we will done with the column minimization step, the next step is to try for the assignment. Okay, so we'll try for the assignment starting from the first row. Just we'll have to keep it in mind that wherever restrictions has been given, we are not going to make any assignment there. Okay, so first row there are 2 zeros. Okay, so we'll go always where only 1 0 is available. Okay, because that is going to be compulsion. 2 0 means there are having alternatives. Okay, so that we can take it afterwards also. So here in second row there is only 1 0. So by making the box, square box, I will assign that in that column no any 0, in that row no any 0. In the third row there is one more 0, so there will be the assignment, and in that row there is no any 0, but in that column there is one more 0, so this extra 0 will be crossed. In the fourth row also there is only 1 0, whereby we can make the assignment, and in that row there is no any extra 0, and even in the column also there is no any extra 0. Okay, so now come to the first row. Okay, because these are remaining as it is. Now when we will having this such type of two options, we can go for either this or this. Okay, that will not make any change. Or already we have done with the row wise, we will go column wise. In first column we have done with, second column we have done with, third column there is a 1 0, so I will make the assignment here, and I will cross the extra 0 in that row. Okay, so it can be done like this. Now if you will count the assignment, this is the 1, this is the 2, this is 3, this is 4 assignment, and we are having 4 jobs and 4 operators. That means 4 rows and 5 jobs and 5 operators. That means 5 different rows and 5 columns. So it means we required 5 assignments, and now we are having the 4 assignments. Okay, you can observe here in the fourth row there is no assignment. Okay, and if column wise you will go, you will observe that in a last column there is no assignment. That means one assignment is lagging. Okay, so we'll do with the process. Now we know the process that whenever we are having this problem, right, so next step is to draw the minimum number of lines, right. Now here are number of rows or columns are 5, so minimum number of line can be 4, 3, 2 or 1. Okay, so it must be less than 5, as order of matrix is 5. Okay, so we'll try to draw such a line whereby maximum zeros will covered in a one line. Okay, so here 2 zeros are there in one row, so we can cover it. So this will be like this. So this line will cover these 2 zeros. We'll call this line as first line. Then second line we can draw here in a column, because there are again 2 zeros. Okay, so second line we have drawn here. Okay, now remaining 2 zeros are there. Okay, so this can be considered, or this can be covered by using either a vertical lines through column or horizontal lines through rows. Okay, we can do anything. So I will go with horizontal lines. So this is the third line, and one more line horizontally in the fourth row. This will be the fourth line. Okay, so you can observe that number of lines are 4. These are less than order of matrix. Let's go for the next step. Now next step is to here. Now next step, in this next step we are going to select smallest element which is uncovered. uncovered means from which line has not passed. Okay, so we'll have to go for three types of operations here. First of all, uncovered elements. Second is covered elements, and third is crossed elements. Okay, so whenever uncovered are there you will have to go for subtraction. For covered there is no any change, and for crossed there is going to be addition. Okay, there is going to be addition. So we'll have to select minimum element from the uncovered. So this is the minimum element from uncovered. Okay, so it means uncovered means from which line has not passed, Okay, so what we are going to do, select minimum or least possible element from the uncovered elements and do the operations like this: subtract from uncovered, no change at the covered, and addition at the crossed. Okay, so let's do one by one. Okay, again wherever restrictions has been provided, it will remain as it is. Let it be crossed, uncovered, or crossed. Okay, so this we will write at the start only, so confusion will not happen. We'll write this restrictions first. Okay, now we'll start. In the first row, here is the cross at the infinity or the first cell, but we are not making it any change because it is a restricted cell. 3 is a covered element. Covered element means no change. 0 is covered, no change. 4 is covered, no change. 0 is covered, no change. In the second row, 2 is crossed. You can observe here 2 lines has been crossed. So whenever crossed, it is addition. Okay, so selected element is 1 and the cell element is 2. 2 plus 1, 3. Infinity as it is. 1 is covered as it is. 0 is covered as it is. 1 is covered as it is. Okay, in the third row, 0 is covered as it is. 2 is uncovered, and for uncovered it is subtraction. So 2 minus 1, it is 1. Infinity as it is. 3 is uncovered, so subtraction. 3 minus 1, 2. 1 is uncovered, 1 is uncovered, 1 is uncovered, so 1 minus 1 is 0. 1 minus 1 is 0. In the fourth row, 3 is crossed, so it is addition. 3 plus 1 is 4. 0 is covered as it is. 2 is covered as it is, and 4 is in the fourth row. 3 is also covered, so as it is. In the fifth row, the first cell, 0 is covered element, so 0 as it is. 2 is uncovered element, so subtraction. 2 minus 1, 1. 1 is uncovered, 1 minus 1, 0. 4 is uncovered, 4 minus 1, 3. Okay, so just we'll have to do 3 operations: uncovered, subtraction, covered, no change, and a crossed. Crossed will be an addition. Okay, now we are done with the operations. Now we'll go for the making assignment. So we'll try to do the assignments now. In the first row, again 2 zeros are there, so we'll do it afterwards. In the second row, only 1 0, so we will make their assignment. Any extra 0 in the same column? No. Any extra 0 in the same row? No, anyone. Okay, in the third row, again there are 2 options, so we'll come it afterwards. In the fourth row, there is only 1 0, so we will make the assignment here. Any 0 in that row is no. Any 0 in that column? No, any 0. In the last row, there are 2 zeros, so we'll come it afterwards because there are options. Now we'll go column wise. In the first column, 2 zeros are there. Okay, so options will come afterwards. In second column, assignment is done. In third column, 2 options. Okay, in fourth column, assignment is just, and in last column there are again 2 options. Okay, so wherever you are now observing, there are 2 options. So in such cases where our options are there, by going row wise also and column wise also, you can start randomly with one of the assignment and automatically all the assignments will be done easily. Okay, in that case there will not be any change in the answer if we will change your start value. Okay, So I will make the assignment here. Automatically this will be crossed. Okay, so it is done with this. In this row I will make the assignment here. Why I am preferring here? Because in this column there are only two zeros, one is crossed, so only one is remaining. So I will make the assignment here. This will be crossed, and because of this has already crossed, so only this is available, only this is available. Okay, so this is how the assignment is made. So once assignments has been made, let's check it out. Number of assignments. So there are 5 assignments. These are first, second, third, fourth and 5, and there are number of rows and columns are 5. So we have got the optimum solution. Now how to write the solution? So we'll write first operator, then job or task, and then time required for performing that job. Okay, so first operator has got the c job. So here is the assignment, so you can check out the value from this. So this value is 6. Okay, c job has given, and the time required is 6. It may be minutes or it may be hours, depending upon the unit that has been given. Okay, so value we have to select from original matrix or the cost matrix. In this second operator, when we consider second operator, he has got d job, the d job, and the time has been allocated in the original matrix is 5. Okay, so 5 is the time. Third operator has assigned with e job. Third operator has assigned with the e job. If we will check out, 7 is the time he has got. Okay, so e and 7. Fourth operator is done with b job or the b task. Okay, and the time is 5. Given time is 5, so we'll write here 5. Fifth operator has assigned with a job, and the time is, again, sorry, this is not the time. So this fifth job